clock schemes. So we use 3 different clock sources that can be used to drive the system clock. So first one is called HSI, or high speed internal clock. So this is 8 megahertz. Of course, oscillators are used to generate the clock signals. That is why we have the oscillators here. You can see oscillators, they are the one generating the clock signals. So everything is inbuilt inside the microcontroller. And we also have the HSE clock, that is the high speed external clock. You can see here, this is high speed internal clock, and this is high speed external clock. The clock speed is 4 megahertz to 32 megahertz. So it's depending on your microcontroller you are choosing. So here the maximum is 32 megahertz clock speed. And we also have the phase locked loop. You simply call this PLL. I think you have studied about oscillators and phase lock loop in your course electronics, I hope, because this is these are the basic concept. You should know how to generate the clock signals and by using different oscillators, and you should also know how this PLL works. But PLL, so this is not important at this point. Just to remember, these are helping us to generate the clock signals. So 3 clock sources, that's correct. And then all peripheral clocks are derived from sys clock, that is the system clock, overall clock. So here you can see the detailed table. So there are different clock. These are the key word we are using inside the programs. So the definition for each clock signal keyword. So here HCLK means that is indicating the high speed AHB clock, and PCLK, and you can see what does it mean. So each one is giving the meaning. So this is the FCPU. This is mainly helping to drive the cortex, that is the core of the microcontroller. And we also have ext.clock, that is external, and this is the VDD to synchronize the power supply with other blocks and so on. So please read this one. These are different terms that we are using also in the program. You will see that inside the program, these keywords. So this is the meaning for those keywords. So here you have to also remember RTC. RTC is another clock. We talked about system clock. It's based on the 3 sources. And another one is called a RTC, real-time clock. Is a computer clock that keeps track of the current time. So that is why in your computer, for example, in the right side bottom, you will see always the current time. So what is the time now? Now it's 11:55. So you will see that clock. How it's possible? Because your microprocessor is also connected to this RTC. Although RTCs are often used in personal computers, that's correct. Personal computers, servers, and embedded systems, they are also present in almost in all the electronic devices, because all the electronic devices are having some kind of microcontroller or microprocessor. So the microcontroller is having this RTC, so you can see the real-time clock. For example, in your home, you have the microwave oven. So you will see the real-time clock somewhere here. And then you will also see in your actual oven, you will see the real-time clock. So these all are because supported by the RTC. So microcontrollers supporting the RTC can be used for chronometers. There are several applications. It also helps us to have alarm clocks, alarm watches, microwave oven, induction, yeah, and so on. There are so many applications are using this RTC. So so we set up alarm right in your cell phone. So what time we have to wake up in the morning, or we have the timers and so on. So everything is based on this RTC. Also, there is some more concept behind this RTC, how the RTC works, how the microcontrollers are talking to the real-time clock. There is another interesting part, but if you are more interested, you can try to Google that. So this is the clock schematic. You remember when we talk about the clock schematic, I showed you in the programming part. we will see the clock schematic. So yeah, so when you install this tool, when you open that, you have a tab. It's called clock configuration. So if you click this clock configuration, you will see the clock schematic. So in this clock schematic, you will see the complete clock signal configurations, how the clock signals are connected to different blocks and what is the prescaler value and so on. So the same one I am showing here now. So you have to connect the theory and the practical. So where we are now, here we are. So yeah, so here you can see the same schematic. You will also see this in the data sheet. But yeah, of course, in the tool, you will see the more live one according to whichever the microcontroller you have chosen. So here you can see all the connections and the prescaler values, and you can change the prescaler values and things like that. If you want to learn more about the clock schemes, I had given the link here. Please go to this link. There is a PDF file. So you will see more detail about the clock resources, different clock sources, and how they are classified and how they are connected. So mostly I have covered the important points, but if you want to know more detail, go into this PDF. So how to set up the clock? Of course, you have to set up the clock for each project. So as the clock setup is a very complicated process. For today's lecture or tutorial, we will just we need some information from CubeMX. In case if you use the CubeMX or Cube IDE, that's not a matter. This is the same. You have to open the tool and then you have to select your microcontroller and the board, and then you have to choose the external crystal. That is the crystal clock. That is the RCC, and you can set the maximum value in the high-speed clock and hit the enter. So these all are, you have to just do that practically. So then you will understand. This is yeah, it's better to see that by yourself. And of course, you can create a project in Kale. After you set up this one, then this scale will take these configurations, whatever you set up. So now we need to include some basic files into our project. So now we are talking about another tool, CubeMX. If you use Cube IDE, then the procedure is a little bit different, but it's similar. So for example, here after you add these configuration files, then you will see in the source directory main.c and rcc configuration.c, rcc configuration.h is the header file. This is the C file. So these are different types of reset and clock controls, and these are bus controls. So I had given detailed procedure on the steps, how to do the clock setups. There are 7 steps you can use. So first you have to enable HSE and wait for the HSE to become ready. And then you have to set up the power enable clock and voltage regulator. And you can configure the flash prefetch and the latency related settings. And also you can set up or configure the prescalars HCLK, PCLK, PCLK2, and then configure the main PLL, and then you can enable the PLL and wait for it to become ready. So whenever you enable, it will take a fraction of seconds or few seconds to become ready, because the microcontroller needs to read your settings, and then select the clock source and wait for it to be set. So for each step, I had given the detail how to do and what command you can use, so that you can see into the detail. So this step 4, step 5 and step 6 and so on. So read this into detail by yourself, and then you will have an idea. So remember, the clock signal is very You don't need to even worry much into the practical part. In the practical part, you just go to the clock configuration part. You will see this schematic. You mainly, sometimes you need to change the clock, or sometimes you need to change the prescaler values. So when I talk about the prescaler value in the upcoming lectures, I will tell you a little more detail. When you change the prescaler value, how it affects the clock speed. Usually prescaler is helping us to slow down the clock speed.